Good afternoon, everyone. Can you hear me?
Yes, teacher. Hello and good
Hello.
afternoon.
Thank you. Can you see my screen, guys?
Yes, teacher.
Okay. Perfect. Okay, guys, let's start the class. For today's class, we are going to have data cleaning and transformation with Python. Like how do we do cleaning and other visualization and other stuffs in Python, so we can go and see. Today's learning outcome is like explain why data cleaning and transformation are critical for reliable data analysis. Identify and handle common data quality issues such as missing values, duplicates, inconsistent types, and outliers. Also apply appropriate strategies for categorical encoding, scaling, and feature engineering. Transfer datetime features effectively and maintain data consistency across datasets. Design and implement two reproducible pre-processing pipeline to prevent data leakaging. These all you can see, and we can go all together. So before let's ask you, which do you think takes more time, collecting data or cleaning it? And should we always delete rows with missing values? Why or why not? What do you think about this? Any idea?
Yes, dear teacher. I think about this question. Which do you think takes more time, collecting data or cleaning it? In my opinion, take more time for collecting data is important because if we collect data very well with a good quality and very carefully, after that, no. After that, it's not a need to cleaning it because when we accurate about the collecting data and also takes more time for collecting this data, it's important to be a good data, to have a good data. Thank you.
Okay, thank you. Anyone else?
Yes, sir.
Yes, Mursal, please go on.
Um, why collecting data or cleaning takes more times? Because it often has error, missing values. Sometimes it has duplicates or they have different formats. Fixing these problems so the data is accurate and usable can take a lot of time. And regarding the second question, we should not delete the data. Um, Always, deleting rows can cause loss of important information, and sometimes it resize the data sets. It's better to fill in missing value and analyze why they are missing. So always we should keep them because they are still useful for us.
Okay, good. Yes, good. Marmar and Mursal, you are correct. Okay. Aisha, you want to also say something? Okay.
Yes, teacher.
Okay. Aisha, go.
Yes, teacher. In the first question, I can say cleaning data usually takes more time than collecting data. And the second question, No, we should not always delete them because we may lose important data.
Okay, shukriya.
I think at the first question, I think both of them takes time because cleaning data also uh, wants time to be cleaned from everywhere, and also if we write them also it takes time. And the
Even eating,
second,
shukriya, eating food also takes time if it is like this.
yes, collecting data.
No, I'm saying that
Collecting.
if you count like this, so eating food also takes time if you eat food. Okay, second one, shukriya.
And the second question is if we delete rows with missing values, yes, it we miss the important things if we delete rows.
I see. You are right. Thank you, shukriya. Zahra. Zahra, are you here? Okay, Atifa.
Can I say, teacher?
Yes, Atifa.
Until Zahra will be present. And teacher, I think collecting data and cleaning data, both of them takes time, but it depends on our ways that we are using. For example, we are using Google Form and online questionnaires that takes least time and it doesn't have any hard working ways. But cleaning data when we don't, when our contact or customer that they are writing the data or filling the Google Forms, they are not familiar and they are very distance far away from ourselves that we cannot speak with them and to how can they fill their form. So they might be fill their questionnaire with missing data, with lots of wrong data that would be not useful for ourselves. So it depends on our collecting and our ways that we are gathering our data. And about the second one, no, it is not right to delete every contact by deleting rows. I think we have to this we have to know about every missing data, how much they are missed, and we can use from the average formula from the upper and the bottom of this contact that they are filling their number and others ways that we can use to fill not delete the rows. Sorry,
Okay,
I'm
thanks,
a little
Atifa. Okay, good. Hasina.
Hello, dear teacher and my lovely classmate. Thank you. About the first question, cleaning data usually take more time than collected because it's a real world data. It's often incomplete, inconsistent, and also it contain with errors. And also we can fix it before analyzing because sometimes it's faced with error points. And about the second question, we should not always delete the rule because of the missing value. It's like going to lead a loss, and also it's important information based on the result. Or we can say instead, missing the data should be handled based on the text And also by using these methods, we can imputation or keeping the data in a good way, or we can say we manage it by this things.
Okay, good, Hasina. Sakina, yes, please.
Yes, sir. Regarding to the first question, from my own perspective, I think that the cleaning data takes more time than collecting data because in cleaning the data sets there might be some errors, some duplicates or wrong formats or outliers, and it really takes more time of the total project time. For example, it might take 60 up to 80% of the total project time. But the collecting data process can be so easily for the one who wants to collect the data. For example, they can collect the data from the surveys, from downloading some projects or some ready data sets. And for the second question, I think it depends on the situation. If the data sets are large and the missing values are not important, so we can delete the rows and it does not have some bad consequences for the data sets. But if the data sets are small and the missing values are really important for the whole project, so we cannot delete the rows.
Okay, thank you, Hasina. Yes, Zahra.
Hello, sir. So my answer is also the same about the first one. So we can say that in practice, data cleaning almost takes more time than data collection because we will have some duplicates and also inconsistent formats, or we may face with some typos and also incorrect units. So when we delete them, it will take more time than the data, and also then the collecting data. And about the second one, so first it depends that whether to delete them depends on why the data is missing and how much is missing. But in general, we can say that no, we should not always delete rows because we may lose some valuable information, and also it can reduce our sample size or just weaken our statistical power.
Thank you. Thank you, everyone. I appreciate your answers. Now let's go and see how much it was close. So it's why data cleaning matters. You can see this picture. This picture is like who wants clean data. So everyone wants clean data, but you say who wants to clean the data? No one wants to do it. So data cleaning is the process of detecting, correcting, and removing inaccurate, incomplete, or irrelevant parts of data to make it suitable for analysis. So think of it as preparing new ingredients before cooking. So it's just like you have some ingredients, but you might need some more to make a good, delicious food or something like this. So you might go again to the bazaar or a supermarket and bring up some more ingredients and then mix it or make it. So that's what it is. If the data is dirty, your analysis or model will produce unreliable results. Like it's like garbage in and garbage out. So it's just like a garbage. You are doing garbage collecting or something like this. So if you don't, if you have dirty, so you cannot rely on your result, and it's not acceptable most of the time because you have not done the hard part of this one. So you can just imagine of this picture when it comes to data cleaning. So recommendation pipeline is like there are some pipelines you should do it when you are doing it, data cleaning. So this is schema and type checks. Before you should go inside your data, you should try to check whether is it relevant to my data types or not. For example, email, your ID number, and also the other columns, maybe age or something, heights or something. Also, you should do remove duplicates, split trend and validation and test, impute missing values, as one of your classmates mentioned about imputations, encode categorical features if there is like male and female, and if you want to do it, so you can use encoding system. And this one is scale numerical features and feature engineering and quality checks and documentation. So this is the pipeline if you are going to do data cleaning or data transformation. So why schema and type check matters? You can see here detects data quality issues before they propagate, prevents downstream errors, like makes pipelines robust and worth. So you can read this one. What we elevate common column names. There might be column names problem, data types, ranges, and format. If I can show you, here's one of the data sets. You can see here. So before you should see, like there could be some problems with if you are doing before if you don't do data types or something like this. So there could be these basic problems inside your someone has not put something like at the gmail.com or something here. I don't know, and some ages might be there. Might be problems with this age and others. You can see here there could be uh, also invalid ID numbers. You can see some of them have used some problems. So that's why you have to do first of all data type or schema validation. So uh, so for this one, if you see it, like this is a small code, like you can see it like what we will try to do it here on this data set. Let's try to work and import and see how it works. So I will open my terminal from there. I will open the notebook. So I will open a new notebook here. Okay. So before I go, so I will just take my Python libraries or modules. I will some do importation, import maybe pandas. I will do it because I'm playing with data cleaning and other things as PD. So you should also try to do it numpy as np, and I will do import rake. What is rake? This is the new library that we are having. Rake in Python. You can go through this one. So this is used for regular expression operation. This module provides regular expression matching operation similar to those found in pair. Okay, so if I go here, yeah. So both patterns and strings to be searched can be Unicode strings as part of this one. So for your validation check or something, so we use rec for this one. For example, if for email ID or IDs, age or something, so we can use this rec, which is a regular expression. So whether it's regular or expression or no, or there might be some has done or some has put another function or something like this. So you can see here. So these are the regular expressions. So you can see all of them, and you can go through the documentation. So if there is ASCII only reg.ascii. If you put reg.a, it is ASCII matching, and if you have other ones, ignore I is ignore cases, local dependent. So these all are you can get from reg. So if you want to do validation or pipeline this schema check, so we will use this module. So you can see import reg, and also I will just try to import maybe matplotlib, because we were matplotlib.py as PLT. So we can see the alerts. We don't need for now this one. We only need maybe pandas and also maybe reg for this portion that we should. So first of all, We will load our data set. It's very easy. df is equal to, can anyone guess what was it? What is our file? So our file is SCV file. You can see comma separated file. So how can we do it? Does anyone know? How was it? PD?
We open the file and read the file.
Yeah, so how we can open the file? So we can say PD dot, we are reading from read CSV, and we are going to give our path here. In here, what is dataset? I will just copy the path, copy as a path, and then I will go here, and then I will just this one, and because it's a long path, so you can put always R here so that it should run. And if I say print, or I say print TF, so you can see, so there are some, this my file is here. So for if it is CSV, so you will write CSV. If it is Excel, you will write underscore Excel to read from this library, pandas library. So it's very good if you want to read your file in Python. So you can just write PD, because we have used the shortcut from here, PD dot what read, as it is read CSV, and we will give our path whether it is everywhere. So this file is in lecture 5 customer activity, so you can see here, and the print df, so it will show you some of the 5 here, and it's also showing you the columns what we are having. Now what we are going to do is like we are going to do basic validation of ID, because if you see here in here, email ID is not proper, you can see, and also this ID is also having problem, and also age. The rest, they have also some problems, but for now we can see for this validation for this. How we do, we just simply use the same format that we were having. So you can say ID pattern. For ID, you can say, so for ID, I can have like, I will just copy paste this one, because it should be this format. My format is this format. If you don't know what is it, so you can just directly, it's a USS format. So you can see here, I can copy. Mostly your format should be like this. In Python, it is giving. So you see import track, and in here there's an example. Oh, it's not giving the example. Let me have write like this. ID rec Python. Maybe this is not. Yeah, it could be somewhere. Yeah, it could be here somewhere. So for ID, so we have our own format. So it's just like it's saying that it should be USR. So it should be three alphabets, and then should be like 3 digits after those one. And for email ID, we can have also the same. So we can check here, and we can go, and if maybe I can do it from ChatGPT to show you better. Do you need to show you in from ChatGPT? Yeah. Rec. So see here, for ID must check USR. So this is and it shares like followed by exactly 3 digits, because it's if you are changing, so it will be 4 digits. It's up to you. So you can get from your Rex pattern. And for this one, it's also a standard email format. So you can see here, W is a 8, and there is .com, so it should be not less than 2. So this is a format that you can find it from here, from ChatGPT, or from anywhere. This is the ID format that you can do it. Now, what we are going to do is, like, we will see our basic schema. So I will say problem or issue. There should be a bracket, and if there is any bracket, list. So I say for I and row. So I'm using condition in F inter rows, and it will iterate all my rows here, and it will find out whether there is problem or something. So for I and row, this one could be row 1, row 2, row 3, and so on. So I will just use condition if not rec, as I said here. I have used rec here, not rec match ID, and also string row user ID. So I can say issues issue dot append. What should I append? I will append my I, comma, user ID, row and also invalid ID. So now I will do some checking here. For email, I will do, this one was for my ID check, because now I can see my ID. If my ID is in the same format that I have discussed, if it is not like this, like 3 words USS, and there should be 3 digits, so it will say invalid or user ID. And then for my other one, for email, so I will say email is equal to a row, and then email. So I will just dot script. If the same, I will just say not in email, not dot match email patron. And then issue the if and append. The same, I will say I, comma, email. Invalid. So there one was invalid ID, but now this is invalid email. So I can see if that's problem. And the last one, yes, Zohra.
Sir, I'm just asking that why did you initialize the regs pattern only for ID and email?
Because I'm just giving example for email, and my email looks very big. So you can see test at example.com. It's something is fine, this one, but in here user.org. So this is not the correct format for this one. You can see
So
here.
for other all also we can do that.
Yeah, you can have as many as if conditions, you can do it. So you can use like for ID now, for example, for age, you can say if id dot not null, you can see, and its row is age, so you can go for age. And what are you going to do it? You will just say if row age is less than 0, if because some people might have put 0 or something, so it could be problem with this one. If it is less than 0 or row age is greater than any threshold that you are saying. If I say 90, if it is greater than 90, so what should I do? I will just say that issue append. There is issue with this one. So issue append. And what should I append? I will say the same. I will do it for this one. So I will say I, comma. So I will say age. Also row, row, and this should be age. And what should I do? I say that its age is out of range. Out of range. So no one can have like 130 years old. So you can say like this. So it's up to you. 90 less than. So it's all a condition that you are going to put for yourself. So if I print now, hopefully it should there not be any problem with typo or something. Dot data frame. Now I can see the data frame and I can see that issue and columns. What columns? I will say columns is equal to row, column, and also value and the problem. Let's run this one. Hopefully input data incomplete input. Okay, I have
Sorry,
put
you forgot one bracket, yeah.
Now there is a good problem. str id should be comma. So it's not dot, it's comma. Let's see what else problem. Email. Row dot email. Okay, because see this one is small email and I have put here capital email. I said row email. It means there should be also. So you can just go and read like this, like email. There is a key error email because my in my column it's small email, but I have given. Okay, let's see. Is there any other problem? Okay, now we can see here. So you can see now this column email. Oh, email. Why? Okay. In column email, this is value bet underscore email. Bet underscore email. This is invalid email. It's wrong because it's not giving you this format. My format is this one. There should be something like there should be alphabets or there should be some emails like Zakir Hussain or something. Then there should be at the rate, and I can see like should be at the rate and there should be some writing and then dot should be a dot format and there should be at least 2 digits after this one. So there is problem with what .com at the rate .com. Also there is another issue is with my age. As I said that it should be greater than 90 and not less than 0, so it's 130. Age out of range, so it's out of range. User ID, this one is also because my user should be using USR 001 pattern like this, but it's using ABC. This is also wrong pattern. So it's invalid ID. And also this one, because there is no any .com or .org, so invalid email. So now you can see now these ones I can find it and I can do based on my schema or basic validations that I can do in Python. Do you have any questions from here, guys?
Please save the code and share with us.
I will give you, it's fine, just understanding matters for me. I will give you all the codes. Okay, so it's also
Yes.
the same. So you have like issue here, like you have a small, so we have done this all here by ourselves. So this is the code it was in Python that we did it. So we did it by ourselves. Okay, now we have another topic, what is missing value. Now after finding out this problem, like basic validation. Now we are handling with missing data. So some values in data sets are missing, like customer's age, a survey response, and detection. So for this one, so we can say df dot is null, if and dot sum. So we can see how many of these we have missing values. So solution is that remove rows, columns with too many missing values, drop null. If you use this function drop null, so it will completely remove your all the row or column. And then we can, other portion is that imputation. So we can fill in the values like numerical, like taking mean, median, mode, some of you mentioned, or categorically most frequent frequencies, sorry, classes. For example, if it's mostly it's green or it is yellow color in your data set something, so you can just do imputations based on the most frequent used colors or anything that comes to you. So you can use categorically or numerically. And forward, backward, fill for time series. So you can do it with time series also. So, and we have three types. You can see here, this is MCAR, MNAR, and MAR. So what is it? MCAR, missing completely and random. No pattern, missingness unrelated to data. Example, some temperature sensor randomly failed. Missing values are unrelated to time and location. So you cannot do it. So you can for because it's like missingly completely and random. So you can just take mean and median or mode. So based on this one, so if there is no pattern or missingness is because of your data sensor or something, so you can see this portion. MAR is missing at random, depends on other variables. Now it depends on the other one, because example is people with lower education are less likely to report income. If you have less income, so you will not, because you are maybe feeling shy or something. So it depends on your income. Reporting your education level, it depends on your income. So missingness depends on education level. So you can see here, a model-based imputation is like regression and machine learning. So you can use machine learning or regression. But this one is MNAR, missing, not at random, is missing for specific reasons. Income not reported. Some people are like girls, they will not say their age, or the boys, they will not say their income. But this is because example is like high income people choose not to report their salary. Missingness depends on the value itself. So some people, they didn't say they didn't answer your question. So this is missing not at random. So it's not randomly, it's because they didn't give you. So add missing indicators or use advanced models. So this one is very difficult to do it by yourself. But for missing completely and random, because you might take mean, median, or mode. But for others, it's very difficult. Do you have any question so far? Any question?
No.
Also, no
Okay.
question.
Okay, let's see for this one, how can we do it in Python? So it's Python code is there, but I will try to write it myself. If there is any problem, we can do it together and we'll see how it works. Okay. So what we can do, first of all, we can see print. I can say df is null. I can check whether is there any null or no. Dot sum of that one and how many of that one is there. If I print this one, so I have a age. In age, I have a missing value. Let's see here. In age, yeah, there is a null value. And last login. In last login, where is last login? Yeah, there is another one, and also weight kg. This one is like weight kg. So I have three missing values. So you can see here based on my uh, columns, these three are missing. One, four. This one is also, and income is also missing. So one is income. So you can go see income. Yeah, income is also, someone has not reported their income. So now if I go and see for example, missing indicators like income missing, so I will say df, you can now choose based on whatever. So I can say income missing. Which column is missing? Income missing. Okay, I will have my own income missing. Now what is it? df income and is null. And now the same, I will just copy paste for age also. I will say age missing. and I'll say what is it? The column is H. So if you say df and bracket, so to give you it shows you to that column. Df is for your data type because I said my file name is df. So in df in my file go to H and is null. So do it like this. Now I can see I can give maybe numerical columns. I can say that what is H. So for all of them, so maybe I can just copy paste, but I cannot do it. So I will just write after it age, income, height, centimeter, weight, kg, purchases, and spent USD. You can see here these ones. You spend US purchases, weight, and this one. So what should I do with this column? So I say for only there is for columns in numerical. So you can see numerical. Now you can see always I'm using for, so it should interact inside my column. For my disk, it will interact. So I will say df column is equal to pd dot to numerical and df for, and you can say errors, maybe errors is equal to storage. So now you can see here, now it's done. Now what I can do, I'm done with this portion with missing values. So now I will go to another portion. Now we can see duplicates and inconsistent data set. If you have duplicates, so like you can see drop duplicates, you can just write drop duplicates. If there is any inconsistent text, like there should be John is like this, like, but have written with space here. So it's a space, John space, but you can write it John without space. So you can just trim white space if you have problem. Fix capitalization. Maybe someone has write with small ones, but you need capital one. Handle Unicode and difference. So this one, maybe someone has like this problem. It should be another one, maybe E or something like this. So there you should have difference whether it's like this or something like that. So you can see here, for example, you have data and you can see drop duplicates. It will just drop it easily. For ourselves, like if we have, do we have any duplicate in our email? Oh, we have one duplicate here. Can you see this one and this one? There is a duplicate. In our email address, we have duplicate. We have in, let's see, city. City is, so this one, we have all of them. See, number 4 and 5 is duplicate. So you can see Bishkek is, and these are all duplicate. Also in gender, we have duplicate. So female, female. So it means that this row is this row is duplicate. So what we can do is we can just write dot duplicate, or we will just have, like we will say df, inside my df, go to email. Now go to email, and what should I do? I'll say df, now write an email. I will say email and dot as type string. If the type is string, string, and dot str dot strip. So these are built-in functions that you can do it. You can go and see all of them, and dot lower for my email. For others, I will also just try to copy this one, and I don't have time, so I will just copy and copy. So I have like city, because my city is also, Bishkek is also here problem. So city, and it, what is it in city? So, and there should be a title for this. And what else we had? We had gender, yeah, female, female. So I will write here gender, and also in gender, what should gender and type is title, and the last one is education. If we go to education, where is education? Yeah, PhD. So this is even all the rows is, so I will just have to do for all. For this much you can do it. Education. Now I will use the same function, very easy function. I can say that df is equal to df dot drop duplicate. Duplicates, and with what subset is equal to user. If I now see, if I drop this one and if I print my df now, now there should not be any. You can see, can you see now there's number 5 is removed here, and this one is number 5 was here, this column was 5, but now it is removed. There's no any duplicates. You can see there is only one of this one. There is no any 5, only there is 4. So in here I have like in this one, for this one you can see that I had problem with my age missing and also income missing in number 3. If you go to number 3, you can see it will show you where I have the missing. So based on this one is null dot. You can see here it shows you the place where it is. So it was in index number 3, and for number 1 income was missing. So if I go to number 1, income was missing. You can see here based on here. Guys, do you have any question?
Yes, sir. If we
Yes,
have
Asha.
2 or 3 multiple sentence, how we can write this in coding?
What do you mean sentence?
Yes, sir. If we have in a large file 2 or 3 sentence duplicate, how we can
So literally, so drop
write.
duplicates, it will go to all. It will go to all. This drop duplicates, it will go to all. Okay? For
Okay.
example, let's see here if this one is PhD and this one is also PhD. Okay, let's do one thing. Let me try to answer your, let me have like this, save it. And if I go, I will go from the beginning. I will run my code here. I will call this one. Now I will do, so I can go here, we go. Now if I print, now you can see in here, see, I had 3 of these one. Can you see now? Who was it? I hope that I answered your, so I just duplicated one more. So you can see this Jen at email dot, this one was 3 times, but in here it's showing you 1 time only. See, at the last one. Because it's used as drop duplicates, it's not one, it's all. Everything that duplicates, and this is based on the user ID.
Okay.
If I see, if I have like, maybe we can try another one. Let's do this one also. Maybe now if I press this one, let's hope it should work. So now you can see here there is 7 of this one, but email is also added here. Now what I copy paste that one, it's also here. So if I go here now, okay, I run this one. Now I will run learn is, see, now you can see income is 2, so there is 2 now, because in here also it was, and in here also. So I just duplicate, so because now, and now if I run this one, okay, can you see, like I have the same 4. Now my this one is duplicate, this duplicate bad email was removed from here too. Did I answer your question? Yes, Mariam, please.
Hello, sir. I hope you are doing well. Thank you for the Chance, so my question is this, that what I understand up to now from these formulas, that through these formulas we can just only find and identify the missing data as duplication or something which is false in our data. It
Yeah.
cannot revise directly by itself. Am I right? Or we have for that any separate formula?
No, so we are cleaning now. At the end, now this is our data. Now when we are running from here,
Okay.
now our data looks like this. So now we can download this data. We can directly download this. So now if I download this one, it will give me my new data set.
Okay, sir.
Now, for
Here
example,
when
if
you
I
write,
say, just a second, I can dot to CSV. Now it was read CSV, I will say to CSV. Now I want to download this one. So if I set to CSV and clean dot CSV, CSV file, and index should be, okay, no problem. So I can say index is equal to false. So no indexing. See, there should be always capital, like, and I can say run. Now if I go maybe here, in data set, if I open, now you can you see, this is my clean data set now that I am doing. Before it was my this data set. This one was my dirty data set that I am playing with. But now, because I am doing my cleaning inside this one, now this is cleaned. You can see cleaned. I just download this one. So now in here you can see those cleaning that I have done. There is no any duplicate here. There is no what was it? There was another duplicate here and others. Also, you can see there was one duplicate here. You can see here. One duplicate was here and one here. Can you see? Now there is only one. So you can just do, at the end, you can just save to and make a new data set for yourself. Mariam.
okay, sir. It means that after identifying the falses and also data missings, we can write the
Yes,
print
you-
here. It will
yes.
directly. Okay, okay. Okay,
Yes, it
understood.
will
Thank
give you, because see here now to CSV, it means to CSV, it means that make it a CSV file. So to CSV, it was read CSV, now it's to CSV. Now after doing this one, now I have my clean data. So whatever operation I'm doing here, it will save here, it will run there, and then at the end it will give me, if I say save it, it will give me clean data. So Zora.
Sir, can we download it to other data file types as well?
Yes, why not? I said to you in here, if you have, let me write here, maybe here. Let me write maybe df2 pd dot. Now if I say read, see, now we can see here Excel sheet, SCV, HTML, JSON, many SQL table, everything you can see. XML, this is from on library of Python. You can read anything in when you are using this pandas library. Okay, it's not
So
only about
could you
CSV file, it's
please
all
show
about file
again?
that you want to. Yes, Zohra?
Could you please show again your cleaned data?
My clean data.
Yeah.
Yeah, it's here. Now I removed the duplicate everything. Now I just made a new CSV file by the
What
name of,
about the missing age, sir?
because in there I have not done anything with the age now, because I just identify the age.
Oh, yeah, okay.
Because I didn't say that you should change it into or something. So I said that only it's showing me in here. Can you see in this code? In this code, it's only showing you the problem. I said problem. What is the problem? So invalid, out of range. Now it's up to you how you will going to like take action on this one. So if you want to delete this one, so you will delete it. If you want to impute by yourself, you can say that, okay, h should be equal to not 30, 130, it should be like this. So you'll just do by this. Because in here, whatever is, I have just seen what is the problem. Because it is just like showing me the schema and basic validation portion. So I said that, okay, in this one I have problem, in this problem, in this, and this. So it's just like this. Did I answer your question, Zohra?
Yes, sir. Thank you.
Okay. Any questions? Anyone else? No question? Great. Okay. So this one was duplicate and data inconsistency. Also, you can do it if their data is just like I said to you, the problem with capital. If there is like small capital and there is space, someone has write like while filling the form, but suddenly there is a space he or she has done put a space inside this one. So you can and capital this one. So you can all do and play, and then at the end you can just get your in data set that you wanna from here. Okay, now there comes handling outliers. As you know that we have z score, like it should be like greater than 3, and interquartile range, which we studied yesterday. So you can see you can use this method q1 25th percentile minus 1.5 multiplied by interquartile, and 25 percentile plus 1.5 multiplied by interquartile. So it's all about mathematics, that the one that you are doing it. So in here you can see that if this one is like greater than this, if it is like your 75%, and if you multiply and add this one, and then it is in this range, so it's fine. Otherwise it is outlier. So you can have like this one. So decision policies keep if valid extreme values. It's up to you whether you will put that extreme value or no. Keep and transport if needed. You can make it. You can manipulate with the data. You can maybe do if it is like more, so you can make it less. So it's up to you. Like we can see it how we can do it, and also document thresholds clearly, and don't delete outliers without strong justification. So you cannot delete it if you don't have any specific like reasoning or something. If I, for example, for this one, if you see my file US spent, you can see here there is like 5,000. Like this one was the duplicates that I did. Now if I go here, maybe like here, you can see like 5,000 is an outlier. Maybe 1,200 is fine. Let's see how is it. So we can just put the same formula. So I will say first my first quadrile is df. In df span, I also go to this. I just copy in my file, go to this folder, and what should I do? I said dot quantile 25% or 0.5. So I will take the first 25 percentile or quartile, and then I will go Q3. I will just copy paste because it's just the same. So I will just copy and paste it here, and then I will say 3, and in here it is 75. So 75. Now you can say interquartile was Q3 minus Q1. So I say 1 QR is equal to Q3 minus Q1. Now I can say, now I can use my this formula, this one QI minus this one. So I'll just maybe I can do copy paste here. I can just copy, not I can say lower is this one, and this one is upper portion. Please let me know if you have problem, if you had some upper is this one. So this one is my lower, Q1 is from my left side, this one is from my left side, and this is from my right side, upper side. So I will say that now I can say I can use clip. So what I can say df, I can, if it is out of range, so I will say that make it less or something like this. So expand, reduce. So I can make another other column for myself, and I'll say that end dot clip. What should I say clip? I can say if it is like between this range, df in a span.usd in lower and upper. So if you can see here my lower and upper, if it is extreme, if it is like outside of this one, so you should just try to clip it, just make it small, or you can just do function by, so it will do by themselves. So I'll say df, and I can show you maybe spend. USD and what was it? Reduced. There is problem with this. Oh, this is is English one. It's not multiply. It's multiply is as x. So this one does not understand. So you should write proper. So see, like it was 250. It was the spending. Spend was fine. This one was fine. But now this is 5,000. But it has made it less. So you can see if I just maybe do one here and one. If I run this one. You see, I have add another column here. This is another column. Now in my this data set, I will not use this one. I can use this one because I said that because it's out, it was out of my this quartile range. It was outlier, but now I can use this one based on my this formula that I said I gave it to. What's the name? Based on this one. So based on this formula, now my 5,000 is in my range. So it's between this range. So this is like 75 percentile or third quartile plus 1.5 times interquartile. So now this is like 5,000 is changed into 2,730. And you can see my new column is here. You can see my new Excel sheet is here. After this, I will not use this one because there was some outliers or something. Now I can use this one. So it's up to me whether I should use this one or my outlier. If it is important, I will use this one. Otherwise, I can say spend reduce this one. So this is my another file that I did it to. So this is all. So you might have like consistency across data sets, like when working with multiple data sources and small inconsistency like common name, mismatches, and different units. So you can see because join errors, duplicate records, and misleading analysis. So you have a lot of problems. So you can see this data set is like I don't know how do you do, but in here outliers may be important because most of your data is as outlier. So you cannot drop all of them. Maybe there is if there is one or two or something, so you could change it. But now because it's all outliers, so you cannot do it. So it's just like this. And then we have here another topic. So let me make it. This is key practices that you can do it. What is key practices? Let me make it small. Align column names and units, standardize column names and a unit across sources. So you'll just make your column names and unit. You should be very fine. Prevent join errors and inaccurate calculation. For example, if it is amount USD versus amount euro, convert to same currency. If it is like USD, so you can also convert this one based on the same day, whether it was like today, based on the same price of today, you can change your euro into USD so that it should be all USD or it should be all euro. Also clean join keys, frame lower, remove extra spaces and special character. So might someone has written all in lowercase or there is using special characters. For example, there might be name as Zakir underscore instead of A. I have reached unders at the rate of under rate. So it's showing me for style or something. So you can just remove these special characters, ensure correct records. For example, here John versus John. And also if you make it small, so because in here it's capital and there is a wide space, and also in here it's small, so you can make it all small or you can make it as a capital letter. So choose proper join type, decide whether inner, left, or based on your analysis. Like if it is, you can use your join function, and also audit rows counts. Compare row counts before and after merge. So because if it is like, yeah, this is also very important when you are using join function or something. If you have 1,000, but after the join function, there might be some portions that you have misplaced or it was not edit. So it might be you have lost 200 your customers or data set. So it's also important that you should not miss any data set if it is relevant to your work. So dealing with irrelevant data, so you can see here, like this is here. So if I just say columns, it will customer name, and if I print, so it will give you fun. You can do it by yourself. Not all columns are useful for analysis or modeling. So because this one is like I don't need the name, so I just use irrelevant df top. Let's run this one. Maybe we can run and see. I will just copy this one and I will go to my here. I run here. Okay, I will run and I will show you. Because in customer, I don't need for this one as customer name because I only need the reason, the age and why did they leave they stop buying. So you can see this df.drop. If you put df.drop, so it will drop relevant data set. So now customer name is drop. Even if you say another one, so you can say instead of this one, you can say age. Now age is removed. So if you wanna remove your column, so you say just dot off. Okay, I hope there should be a video at this portion for you. Then we can see and we can move on. If you have before, I should put for you a video. Do you have any question, guys? Please let me know. Is everything clear?
Yes, sir. Sorry.
Okay, let me go here. We can remove our friend. Our friend is here. Okay, let me put this one. Hopefully it should work. Okay. But it's very interesting when you start doing it. Can you hear the mic?
What's going on, everybody? Welcome back to another video. Today, we're going to be talking all about data cleaning. Now, data cleaning is an essential part of working with any data. And so this is a very core fundamental concept that anybody who works with data will need to know. As a data analyst, I've cleaned data in almost any way that you can imagine. So I am very excited to talk about this topic. Let's not waste any time. Let's jump on my screen and take a look. All right, so let's take a look at what data cleaning actually is. Data cleaning is the process of identifying and fixing issues, aka dirty data, in your data to ensure it's accurate, consistent, and complete. Let's take a look at these patient names on the right-hand side really quickly. These are all my names, but just in different versions or variation. This is very dirty. So we have Alex Freeberg, Alexander Freeberg, Alex F, Alexander F, Alex Freeberg with a U, Alejandro Freeberg. These are all the same person. That's all me. But if you're looking at this in a database, it's going to consider all these people different. And so what we would have to do to clean up this data is we would have to make all of these names consistent and the same. Maybe we do that by saying, okay, all these people have the same date of birth. They're all male. They all have the same social security number. So with all of those things, we could say, yes, these are all the same person. We could make all of these patient names Alex Freeberg with an E. That would really clean up this data a lot. Why do we need to clean data at all? What is the reason that we do this? One is to ensure accuracy, because you're going to be giving this data to stakeholders or your boss or a customer, and they're going to expect that this data is accurate. But if you're giving them bad data, then they may make bad decisions with that data, and that's going to come back on you. Next, it improves efficiency. When you are working with clean data, it is 10 times easier to analyze and use that data in any way you need, rather than it being really messy and really difficult to work with. Lastly, it builds trust. And stakeholders and customers and clients, they want to be able to trust that what you're giving them, the data that you're using, is actually accurate and complete. And so those stakeholders are really going to trust you if that data is clean and accurate and you can find insights with that data. Now let's take a look at some other examples of dirty data. And these are not all of the examples, but these are many of them. Here in this data, we have columns and rows like an Excel file. We have a name, a phone number, an email address, and an address. In each of these, you can see a lot of mistakes. Take, for example, in the name column, we have things like punctuation marks and abbreviations. These are the same person, just like we looked at in the example with my name. These are all the same person, but each of these records requires a different row of data because it isn't standardized or cleaned. Let's look at phone number. This one shows us missing data. And this is a very common one where you're collecting phone numbers and all of a sudden you just don't have a phone number. So you're missing that data. Now, what are you going to do with that when you're cleaning it? Maybe you need to populate that data. Maybe that is something that you can get from another data source, or you know it and you can actually put it in there. That is a way you can clean that data up. Next, we have mixed numbers and letters. It may look like 831.262.2149, but that 1 is actually an L. And so this is just a classic case of bad data. They should all be in the same format with the phone number, but they're not. Some have dashes, some have commas, some don't have anything, and some even have letters. That's very, very messy. Next, we have email address. Now, within this one, they're all somewhat different, right? We all have different email addresses. And again, that's just a standardization, making them all the same issue. But we also have something like a non-printable character. Now, there are specific characters within computer systems that you just shouldn't be putting or really can't put in specific data types. So if this is a string, that may be a character that you shouldn't have or can't have, that's going to mess up your data. Lastly, in the address section, we have two issues here. We have messy structure and format. So some are capitalized. So some of the data is capitalized versus not capitalized. We also have incomplete data. For example, we have Emily Renzelli Boulevard, but we don't have a number, we don't have a city, we don't have a state. There's just incomplete, and that makes it really difficult to work with that data. Now, here we have something called a data cleaning cycle. And I really like this visualization because it shows that data cleaning is not just a one-time thing. It is something that you have to continuously do. And I've experienced this a lot over my years as a data analyst. Once you clean data, it isn't necessarily perfectly cleaned. You kind of have to go back and clean it as you go, and it's never really perfect. It's just really usable. This cycle typically starts at the very top. So we have importing data. This is just bringing in data from other systems, usually through some data collection system, like a data pipeline that we talked about in the data collection lesson last time. Next, we have merging datasets. This is combining multiple data sources into one dataset. Next, we have rebuilding missing data. This is where you're handling incomplete data, or you're actually filling in that missing data. Next, we have standardization and normalization. Standardization is where you're making sure that the data follows a consistent format. So all the date formats are the same. For example, if we go back to this one, we can make sure that the address is all standardized. They all have an address, a city, a state, and maybe a zip code if you need. They all have the same data. Next, we have normalization. This is a little bit different because you're adjusting data to a common scale without distorting the data itself. Next, we have deduplication, and this is where you may have duplicates of data in your columns. For example, maybe we have 100 columns of Alex Freeberg, and we don't need 100 columns. It's all the exact same data. We would want to remove 99 of those to just keep the one that we actually need. Next, we have what they call verification and enrichment. This is really just data quality. You're going through and you're validating your data, making sure that your data is accurate. Then lastly, you're saving this clean data in the format that you need for your next processes, whether it's analyzing or you're using it in some type of product. Now, one thing I want to mention on here is that this cycle is not perfect. In fact, I usually do deduplication earlier on within this cycle, but it really depends on the data itself. Sometimes you're importing, merging, rebuilding, and then going back and getting more data, and then importing, merging, and rebuilding. So this isn't a perfect cycle. This isn't exactly what you should do every time, but these are often the steps that I am taking when I'm cleaning data. The data cleaning is very specific to different tools, and I have a lot of different videos on how to exactly clean data with full projects on data cleaning in SQL and Tableau and Power BI and Python and Excel. And so if you want to learn hands-on how to actually clean data, go check out those videos because they are fantastic to learn how to actually clean data. With that being said, thank you guys so much.
Okay. So do you have questions so far from here?
No, sir. Need more practice.
Yes, you're right. Thank you. Okay. So now we have like another one is
Sir?
like
Sorry, sir.
yes, please.
Sir, can we identify from PDF also?
For PDF, it's very hard. Like how you want to do it from PDF? Yeah, we have another library. We have another library. It is just a second. What was PyPDF? I think it was PyPDF. Yeah, PyPDF 2. It's here in a model. So PyPDF2 is a free and open source pure Python PDF library capable of splitting, merging, copying, and transforming page of PDFs. It can also custom data viewing options and password to PDF. files. You can see here, now you can see here, like you can have naming adjustment, reports, asterisk, exceptions, warnings, and logs. You can do all of them here. So you can use this library. But it's this, oh, this one, use PDF too. It should be this one, but why is not? It is here, extracts from PDF, so you can extract text from PDF. So you can see here, like from PDF, this one from PDF to import by reader. So you have the same, you are using read, but in here you say PD reader example.pdf, and what is page number 1. So it will extract. So it will extract for you, and if you print this one, it will print for you. So you can have this as your. You can read to this. You can go through this documentation and read all of them. So you can use this as your reference by PDF. Okay.
Thank you so much.
Yeah, so you can have this one. So this is also very good. This one, even for what also there was, I forgot the name. Let's see how to read. I forgot the module. What was it? How to read image word in Python. Which one file in Python? Ah, yeah. Python.pdf. Yeah, from docs, import document. So you can see from, and then you have your documents, and you can have docs. Yeah, you can use this library. So if you want to do it from Word, so you can use from docs. So in here you can say allows you to create new documents as well as make changes on existing ones. Actually, it only lets you make changes to existing documents. It's just if you start with the document does not have any content, it may okay. Then you can have here, yeah. So see foobar dot this one, it will just do it. So you can have like docs. So how to read word this one, you can see, you can go through these videos.
Hello, everyone. For Linux, go ahead and type
So I will not go
edit
so you
underscore.
can do it. Okay, Asra. Okay. So now data transformation. Data transformation is the process of converting raw, messy, and unstructured data into structured, clean, and analyze ready format. So now after cleaning, it is form transformation. It involves changing values, modifying structure, and combining multiple data sources to make the data more useful for analyze and modeling. Now you found out your problem, where is your problem? Now you can take your transformation. If it is like unstructured data, or you have to do it clean and analyze ready format. So what is it? Now, for example, here, categorical encoding, one hot encoding. One hot encoding is just like it's used for like you have like red, like color red, blue, green. It's like in categories, but you wanna present it into 1-0. So you can use one hot encoding for this one. It helps models learn patterns without introducing ordinal biases. So without learning like it's red, blue, or something, so it will start do it if it is present. If red is present, so it will be 1. If not, so it will be 0. So instead of this one, it will make a row red, and it will have like red present, yes. In this row, in this column, red present, no, it will be 0. It will give you like proper encoding, one hot encoding. So if it is present, so it will give you 1. If not, 0. So its hashing trick converts categories to find a fixed number of hash brackets, and also target encoding replace each category with a statistic of the target. So important consideration is fit encoders only on training data to prevent data leakage. Handle unseen categories, so you can it will come to machine learning, because you have to do it everything encoders, everything in your training, not in testing later, because in testing it will have data leakage, but for preventing this one, so you can do it in training data. Handle unseen categories and interference, like ignore always documents your encoding. So because you should give documentation, because it's very hard. Now, for example, here. Oh, I have a code also here. So you have like red, yellow, green. This is your one column. For this one, what I do, I make another separate column for each one. For red, for yellow, for green. So I say for the first one, red. Isn't? Yes, it's 1. At present, yes. In here, present, no, 0, because it's yellow. 0, 0. So it's if it is present, you will put 1. If not, 0, 0, 0. For yellow, 0, 0, because it's red, and it's here, it's yellow, yellow. Yes, it's present. So the same it goes. So you will just change this one into 0, 1, because it's very easy to read by computer, this format, one hot encoding. Let's see if I can run this code here. Let me delete these. I can go here. I have the same example: red, blue, green, green, red. So let me run this one. Hopefully it should work. So you can see here now they have made it here for 0, blue color. For the first one, it's red. It was not blue. 0, 0, and it was color red. Yes, it's 1. And for blue, for the second one is which is 1. Blue is here. Yes, this one is 0, 0. So this is one hot encoding that you can do it. You can do categories data into 0 and 1. It's only low cordility. So you can go from using this one hot encoder. If you click on this one, so this is the.
Sorry, why the number is float?
Why the number is what?
Float.
Can you please come again? What is the number?
It's printed like the float. 0.0. Not just 0.
It's fine. It's fine. It's just like 0 and 1. It's fine. Okay, it's from inside. And it will understand this one. It's an encoded version, so it's encoded. It's encoded inside your disk, so it's fine. You can have 0 or 0.0. Fine. Okay, in here, maybe you can have. So this is the documentation. You can go for and read all of them here. You can find the encoding here. So encode category features as one hot encoding numerical arrays. So you can have it here. All the encoding here. Maybe there is example. Feed X. Let's see here if it works here. Maybe because it's 1 for male, 3 for. You can see here it's also Shukriya. It's also like, see, 1.0. It's float number, so it's already encoded inside your system. Maybe this one. You can go through this library by yourself. Korea is also like float number, so it's already encoded. So so 1 is in here. It's 0. It means it's female. Female is 1 and male is 2. So we have 1 and 2. So 0 is not present. 1 is present. So you can go through this one. So it's like male. Male is 2 times. So you can see 2 times. So it's 1 and 1. But for female, it's 1 time. So you can see here 1. So you can see based on this one, and you can go and read the documentation by this one. So it's a scikit-learn feature. You can do it here. Then we have scaling and normalization, which you saw in the video also. It is just like standardized. You have like a formula in mathematics, x minus mu divided by standard deviation. So central data at mean 0 and standard 1. So you will just standardize it between 0 and 1. Like your mean should be 0 and standard deviation should be 1. It's best for KNN, support vector machine, and linear models. So in machine learning, you can see this one helps ensure all features can contribute equally to the model. It's to make the model looks like is all equal. So you can use standardization, or if it is like normalization is rescaled to 0 and 1. So if you have your data, so it will give you between 0 and 1. So it keeps data within a fixed range of 0 and 1 in normalization, used for algorithms sensitive to feature magnitudes, neural networks, gradient descent, and this one. So often used for features like pixel values. If you have pixel values like in images, so you will use normalization, percentage, and sensor readings. A good practice is always fit scalar on training data only. So again, you will do it in training. So you just learn it in machine learning portion, apply the same transformation to validation and test sets. And treat this best is random forest. XGBoost usually don't need scaling. So you can understand it later when you practice with machine learning. So this is for machine learning. So when you are, because when you are cleaning and transformation, so it's all because for you are doing it for your machine learning and deep learning. For example, neural networks and this gradient descent support vector, these are all machine learning concepts. So you can see here, like it's between, like mu is 0 and standard deviation is 1. So it's like your standard deviation scaling. And this one is your normalization. You can have C comma, okay, we have a code here. So it's just like example is very simple. You can go here and we can copy paste this one. So in here you can see it's again sklearn dot preprocessing import is standard scalar. So it's already embedded and min max scalar. So scalarization is here. You can call standard scalar. This is self is here. You can call this method and dot fit and support. So it will give you now your see it was 160, 170, 180, but now it's giving you between this range 0 and 1. It mean is should be 0 and the standard should be 1. So it's minus 1.22. This one is here. So this is for your first one, and this one is your normalization for this one. You can have your this range of 160, 170, 180 numbers into 0 and 1. So you can see for normalization it's 0, 0 0.5, 0 0.5 or 1, 1. So it's up to you how you is going to do it. So you can use standard scalar and min max scalar. You can go and see the documentation in details later. You can go here, even it's in the same in scikit-learn. So this is the documentation, and the formula is all about mathematics. You can see here, this is like this is normalization. You can see all of here, and there is also examples. Like this is in between 1, minus 1, 1, 0.5, but it will just scale it into this format, to smaller format. Then we have a very important topic is data time transformation. Like there might be problems. Always spare data types with correct time zones and daylight saving time awareness to avoid drift and misleading. So there could be problem with your data type. So you will just say like DF year and month. These ones all you see it. We can see it in example here. Feature extraction year, month, day, week, hour. So this can be weekend flex, Saturday, Sunday is equal to 1. So you can have, if it is weekend, you can put it yourself is equal to 1. Holiday flex based on calendars on custom list. And this all you can do it in here. Like let's go and see in here. If I go my, so this is my data frame. You can see here it's like 23.00. This one is 1st January 2020. To 4, and this one is 2nd January 2024. If I see here, now you can see the year is here. You can see the year, month, do, hours, like it's what is weekend, is it weekend or no, and hour sign, you can all use it here. So extract feature, you can say year, you can say, and this is like df ts, because this is my ts dot t dot year. So this is to year. So it will show you the year, month, day of week. Day of week is here. Whether it's because it's 23 was here, it was midnight, it was near to midnight. It's not a day of week, it's night. But in here, this one is at 1. So it means that it is day of week. And also hour, and also is weekend. You can write like this is weekend. So if it is weekend, so you can see 5 and 6. Integer you can see is not, but it could be like maybe weekend time. Maybe let's change the date into 3, maybe 3 we can save it. Let's see, maybe for here 3 and in here 6. Was it 6? Let's see if it works. We can for even okay, let's see. So you can see is weekend now it's 1. Now it was like because if you see your calendar, this date 3rd of January 2026, it's Saturday. Now it's showing you is weekend. Yes, it's 0. You can and you can check every portion if you want, and you can bring changes if you need based on your need, that what you need from there. So main goal is improve data quality in data cleaning, but in here make data structured and analyze ready, because you are using normalization, scalar. So it's all about you should analyze your data with data transformation. But in here you can see improve the data quality. So fixing errors, inconsistency, and missing values. But in here changing format. If it is data type is not correct, so you will change the type of this one, like daytime or nighttime, whatsoever structure, or creating new features. So the main topic is basically is handling missing values, remove duplicates, fix typos, formats, correct outliers. But in here, encode categorical variables, scale and normalize values. It's all things here. You can do it because you can see example is like here this example, but in here is data type portion. So you can see the hour, you can see the day or something like this. So you can see the structure of your data in data transformation. So it should be clean and consistent raw data. It's raw data, but now it's structure, feature rich data set ready to analyze and modeling. So first of all, you will do data cleaning and then you go to data transformation. You can see here data transformation gets new meaningful variables from existing data. It helps models capture patterns, reduce noise, and improve performance. Especially useful in feature engineering for machine learning and time series. So while you are going to do it machine learning, then after data cleaning, you are going to do it feature transformation. So these are all, you can go through these ones like filtering and grouping, weighting and reshaping, binning, feature process and logs, and rolling and flag features. So you can see for filtering and grouping, summarize and aggregate data for key columns, like dot, you can see here group by region. So if you want to have group by region, so it will give you the region of like Kabul. If you say region by region, it will give Kabul, Herat, Mazar all in as a region, and it will sum it. And the same you can go through this one. Pivot is the same as Excel one. So reshaping, convert rows, columns, and long and wide. So you can reorganize data for modeling or visualization, handle skewed distribution, simplify patterns. This all works here very well. So these are some common techniques that you can do it. So for this one, pandas, NumPy, and scikit-learn preprocessing. You can see here in here, if you one is scikit-learn, sklearn dot preprocessing import scalar. So in here we use for preprocessing. In here we were using pandas and NumPy. So these are the libraries that when you are going to do it for data cleaning and data transformation, you can use it in your data set. If any question, guys, so far?
No.
Is it difficult or is it good?
Is it so difficult, sir?
Is it so difficult? No, it's not difficult. It's just like when you will start doing it, so you will just see the pipeline. What pipeline? This pipeline where it was here. So see, now first of all, you will do data type checks, remove duplicates, like then validation, imputation, and missing values, what you are doing. And now it comes to your transformation. See, category features, if it is one encoding, if it's like green, red, or gender-wise, male, female, because we cannot do it male, female, so you can put male as a present, one present, if not present, 0. So this one you can do for genders. Mostly people, we are doing for genders, this one hot encoding, and for giving ratings like average, good, bad, these ones if you are going to hotel or something. So if it matters for you this rating, so you can use one hot encoding. And scaling is just like putting everything inside between 0 and 1 by using normalization, or scaling is just like scalar. The mu should be 0 and standard deviation should be 1. So this is all about feature engineering when you are going to do it. So in in real world you can see how it works. Okay.
It's interesting, sir.
Yeah, it's very good. Like you can see here, like, so this is some of the features that you can do. So if it is like you can see some of you, Shukriya, you are saying about this floating. It is float. So even you can change from float into integer. It's up to you. If you need integer, you can change everyone based on what you need. So then you can do it. Okay. So now you have your we are on time for your break.
Isn't it
Yeah,
time
please
to take a
take. Yes, so we are on time. Please take your break and we will come after the break. Please come by how many 15 minutes?
15 minutes? Yeah, that would be
Yes, please
great.
take your 15 minutes. Then we will see another good topic. It is also a very good one, data visualization. Now we are going to see data visualization. Okay?
Thank you,
Okay, see you
sir.
then. Okay, take a rest.
Uh, Teacher, me, Sina.
No, Zahra, just a second. Zahra, yes, please.
I think that it's better to do ourselves.
Zahra, what did you say? I couldn't hear you. Do you repeat?
I think that it's better to do ourselves than
Okay,
to
so you should
each
do it
project.
yourself. So
Yes,
you can have 2 or 3 members in a group. So you can have in a group, you will work in a group. So you will just do it and then you will be done.
yes, of course, it's better.
Okay. During the Shukriya, the break, have you discussed? Yes, no midterm, only final exam and presentation, project presentation. So your last class will be on Monday. Next Monday you will have your last class. Then Tuesday is off. Wednesday you will present your projects, which you will work in a. You can do it individually or you can work in a group if you want. If you need a data set, I can give you data set. You can do it, or you can have your own data set. You can come and you can do this data cleaning, transformation, or other topics, machine learning, and other ones if you are interested. So we can do it together. Where we should submit our homework. Just a second. So you can do it in there. And this like graphs, you can do the visualization. So I should understand that you have just worked or you have understood something. Something. Not all, I cannot say that all of them, but at least some of the topics that you have understood properly. This is your, and on Thursday, then you will have your final exam, which is a written exam that you will just write and send it to me. Just a second, Zohra. There is a question, where should we submit our homework? Suraya, I don't know which homework you are discussing. You mean assignments? If you are talking about assignment, if you are saying about assignment, homework should be, yeah, by email or WhatsApp. But please, students, some of you have like 24 hours this WhatsApp that your emails, these messages are deleted. So please don't do it. If you have this problem, please send it to me by email, not by some of you. I don't know of you. They have this problem 24 hours. You should know better. So please remove that one, or you can send through email because I cannot see in 24 hours. I just opened and it was gone. So I wrote well received at that time, but later that I was going to grade or check it, so there was nothing inside. So all messages were deleted. So please send me those. It was, sir, please talk about exam again. Okay, sir, just let me discuss about this one. So please, if those one who knows that it was like 24 hours message, this something problem or something like that in WhatsApp. So please send me again for in email if you have this issue. So if you have default
Your
timer.
your WhatsApp is 24-hour disappearing message or ours?
No. Yours. I don't have. My one is not. Those students that they have default timer for disappearing messages for 24 hours. Please send me again. Not mine. I don't have. My one is full access. I have others work like yesterday. Let me see. Yeah, for you, for example, Shukriya, you sent to me. I have your homework with myself. Assignment one, two. All of them I have yours, Shukriya. But for others, I don't know. There were some two of those. Then yes, about Zahra, about final exam. It's just like Can you give us a specific task for final exam? I think it's better. It will be your presentation, Suraya. Final exam is your paperwork. You will just have some paper. On the paper, you will solve some question. This some definition or something. You will do it by yourself. Okay. Anahita, just be quick. We will go to our second portion of our class.
Okay, sure. Thank you. So just one question. Will our marks from the quiz affect on our final certificate? Because this time I got 1 mark less than the full mark in the quiz.
Come on, if you need, just a minute. Perfect. So, students, now we have another concept. It is what is data visualization? It's, as you know, it is a graphical representation of information data using visual elements such as charts, graphs, maps to make complex information easier to understand, analyze, and use of decision making. So we have plenty of graphs or good things in Python, like modules. We have matplotlib, seaborn, plotly. We have many of these libraries that you can use it, and you can visualize your graphs, charts, or whatsoever, your data. So it is easier to use trends than read tables, helps identify outliers and anomalies if there is any missing these big amounts of numbers, or there is any problem anomalies, so you can check this one through your graphs. Initial for exploratory data analysis, EDA, and making a story link with data. When you are going to present your work to your boss or to your friends or in a lecture or anywhere, so data is very good to show the story that how did you do and what was the impact of this on your data set or in your assumptions that you have made it. When to use visualization, explore patterns in raw data, communicating findings to non-technical audience. If you, for example, if you are presenting to your audience, they don't know about your field or something, so graphs are very good if they are not technical people giving a seminar to people like not related to your field or something about your field. So it's very good. Comparing groups, categories, and trends, you can just see what is the impact of age and gender on gender, education, this one. So you can just compare everything. And also support decision making in reports and dashboards. So you can take decisions that which feature should I use and which I should not use. So these are very good. So we have types of visualization. We have like a lot of this one. So you have univariate, one variable, bivariate is like 2 variables, multivariate is 3 or more variables. Time series we have change over time, and advanced visualization like maps, networks, hierarchies. We are having this all of them. So we will go one by one and see what are these on which graphs represent univariate and bivariate. So first one is univariate plots or visualization that shows the distribution frequency. So the distribution frequency and summary statistics of one variable at a time. To find one variable at a time, like gender or like male, female or something. So it's one variable. Understand how values are spread, detect outliers and identify the shape of the data. So values of spread, how is it spread? So you can see histogram, box plot, it's also called whisker plot, and also bar chart. So you can have this for these three as a uni. So use cases understand certain central tendency. You can see visualize mean, median, and mode. Show where the data points are concentrated, where it's mostly used, or where is the peak of these points. Useful for descriptive statistics and comparing with expected values. Spot skewness and distribution shape, like left skews, right skews, if there is some problem with your data. So if it is maybe it's not bell curve, so you can see left skews, right skews, this one. And also helps choose appropriate statistical tests, like identifies heavy trails and unusual patterns in data. Detect data quality issues, highlights outliers, missing values, and data entry errors. So which was in a very small, you can see that it's how values are spread, detect outliers, and identify the shape of the data. So this is just, so you can see histogram is just like this. You can see, so now it's what is it? Is it right skewed or left skewed?
It's right.
Is it right skewed
Left.
or left? I think it's left skewed, yeah, because it's the
Yes.
more data is on the left side, so that's why. So you can see box plot. Box plot is just like you can see here, like you have this one as your, like this one is your 1.5 interquartile from this, and this one is your median. This is your in here it is your 25 percentile, and this is 75 percentile. You can see this one. So based on this one, so box plot is here. Then you have bar chart, so it's just like a bar. So you can see bar chart. You have worked with Excel a lot with histogram, but in histogram it's connected, but in bar chart it's disconnected, joined from each other. Then you have bivariate Poillard's visualization, the relationship between two variables, one like salary and education. So there is two variables at a time. So you can see detect linear or nonlinear relationships, spot outliers or unusual patterns, explore different group difference between categories, and also guide feature engineering and model selection. So it is identify correlations, trends, and comparisons between variables. So you have numerical versus numerical. You have like if it is you have a scatter plot for numericals, X-bin, and line plot. So for example, if it is income versus income, both of them are numerical. So you can have like in digits, or temperature versus energy use. You can check correlation trends. Categories versus numerical, it is box plot or violent plot and bar plot. Income versus by education level and sales by region. So you can see one is region is category and sales is numerical. So you can have compare group difference. Also categorical versus categorical is clustered bar or mosaic heat map. So you can say gender versus purchase decision. So based on gender, male or female. So by purchase decision, will they buy it or no? It's just like category versus. So identify associations. So you can see scatter plot is just like dots. You can see it's just like this. Line chart is like based on the line. You can see line chart is stacked. Box plot is just like on the they you can compare both of them by side by side. So spider is like this one and worm is this. So you can check which one likes apple and which eats orange. So it's up to you. So this is the stacked bar box plot. Then we have multivariate, so 3 and plus variables. So you can see shows interaction among 3 or more variables at once. Explore complex relationships and find patterns that might be missed in univariate or bivariate. So identify interaction effects among variables, detect redundant or high correlated features, understand nonlinear relationship and group structure, support better model decision or something like this. So you have heat map, you have peer plot and stacked bar chart and parallel coordinates plot. So heat map is strengthened for relationship between multivariate. So this is mostly used correlation for correlation matrix, heat map, scatter plot matrix, scatter plots for every possible pair of variables. So and also you can go through these words. So you can see here peer plot. You can see here this is peer plot. This is like you can see all of them inside. What is it? Is it there are some maybe species? I think this is species. Yeah. So you have to see, and this is like parallel coordinate plot. This is your. This is how it looks. Correlation is this, and this is bubble. This is like a 3D bubble plot. You can make like these graphs and also multi subplots. You can see all together Thursday, Friday, Saturday, Sunday. It could be total billing of someone. It's for female and it's male. So you can see all in one graph as multivariate. Then we have time series visualization. It's our plots that shows how data changes over time, daily, monthly, weekly, yearly. So understand long-term trends, upward, downwards. So you can see it's a line, like as a line. Detect seasonal patterns or periodical fluctuations, spot anomalies and irregular spikes, and support data-driven forecasting and planning. How it is, like you can see here. So you can see over period of time. So you can see it's all in 2020, 2022, 2010, like this. So you have another one. So you have line chart. This is like line chart. You have area chart, and this one is very simple bar chart monthly. This one is your bar chart. So you can see over period of year in April, and this one is increases this much, then this is a decrease, there is an increase, decrease again, increase. So you can check based on this one. So it's continuous trend, you can say it's continuous. National park, national parkway, these outfronts. So it's US national park visitations by design data. So people are 120 million park visitors. So there are people that they visited, and it's showing you over that period of time. The same is area under the curve, area chart. So you can see mobile, the usages, then you can see TV, it's on top of each other. In advanced data visualization, we have beyond simple charts to represent complex and hierarchical and special data, provide deeper insights of large, complex, and structured data sets. Like you can see, so it's excellent for data dashboards, presentation, and data storytelling. How it is, we can see. So, for example, you have geographical maps like this. You can make graphs like of all countries. Like you can see, there could be Afghanistan, somewhere here, Afghanistan. This is by country. So this could be the life expectancies of by country. So people in this area, they live by average is like 83 years. But in here is also 83, it's 68, 66, 67. So based on this one, you can see based all over the country. So data across locations or regions, cells by country, population density, and disease spread. If you have any disease, so you can also check, okay, based on what this one. Tree maps, you can see tree maps, hierarchical data using nested rectangles. So we can see this one, and network graphs, relationship and connection between nodes. I think they have, yeah. So we have tree maps. So this is the share of like Google. It's in America, for example, Nvidia, Microsoft, Apple. These are Amazon, Tesla. These are. So you can see this is based on tree maps. So you can see all the shares. So in here, Google, it was minus 1.31%. Meta is plus 1.89. So you can see all the shares of all the companies here, and you can see analyze this one, which one was doing good or which one was doing bad. So Apple was plus 0.74%. So it has gained profit, but in here Google lost it. So the same goes with others. So you can use tree maps graphs, and also network graphs is just like here. You can see this is network. For example, this is person A. This is the place. So this one is species. I think there should be some problem with animals species. For example, this is like network. So you can see this is one is your home. So you have problem with, you have like some relatives here, maybe your enemies are here. So it's all about network graphs. So chart selection and design. Do you have questions so far, guys? I think
No,
it's
sir, no
easy.
question. Yeah, it was clear and easy.
Yeah, it is clear and easy. So in here, questions is, well, how is one variable distributed? Recommended is like histogram. If you have one variable, so you can use histogram, box plot, bar chart. If you have two variables, scatter plot, and these ones. And then if you have like how to multiple variables in direction, you can use heat map and change over time. You can see line chart and where it's going. So you can use math or these tree maps. So before this one, let's see some examples. Maybe we have some times we can go and just do some coding. How it? Okay, let's see maybe for our this data set that we were having this one. So I hope like let's go for H. Maybe we can go for H. We can have one variable. We can say, so this is how you can say, so you can find PLT figure. You will just make a figure. So C is PLT. So it means that I am using this module PLT SPL. So I'm using matplotlib. So I'll say just make a figure and df on what? I will say on H. What should I make? So now I can say dot hist. It will give me histogram. So for others also you can say you can use based on this one. So I can show you later. So you can have plt dot title, maybe title. I'll say H, and then maybe H distribution, because it's distribution. Then you have x-axis plt dot x label. So this one is for x label. If you have x label, it is h, and plt dot y label. So you have your y axis. So I'll say count, and then you can say, now at the end you can say plt dot show. If you say, it will show you. What is the problem here? Okay, let's run again from the beginning, because maybe there should be problem with our data set. I don't want to do this one. This one maybe not this saving. Okay. Let's see. Oh, so because if you don't run Jupyter for a long time, so you need to, because it will just restart, so it will not understand. So you can see here, this is your average distribution. So based on this one, if you go to histogram, now histogram in Python, you can go there, you can find these codes here. So you can see PLT floors. So you can see it's just like here, you can see, and now you can see the exact. So there is some random variables, they have created random. So now you can see, now they have set random, and see plt dot hist of x. So this is the random variable they have generated, a random, like this is a random variable that they have generated. So it's just giving you like the same. So you can check based on this one. You can go here and see more and more. Or just a second, maybe see, you can have beans, you have density, range, everything. If you need everything like this one, you can have like this beautiful one. So it's a random generation of some variables. It's from 1 to 1000 when random numbers. Basic is like hist, and data, this data is given, and beans, 30 beans. How many beans should be there? How many of this one is 30? Color, you can change the color, sky blue, so this is sky blue. Edge color is black, so you can see these edges are black here, and these ones you can. X-axis is values, you can see here value, y-axis is frequency, and also plt title is basic histogram. So this is your title, and when you say display the plot, it's showing you. We can even run this one here on our here also. So I can go here, you can just play with this. Now you can, it's working. Now is instead of this one, maybe I can say yellow. It's giving you yellow. Instead of black, maybe I can say red. So you can play with this one. You can go, instead of this 30, I can say maybe 10. So you have 10 of this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10. So you can play. So beans, you can go through this documentation and you can see how many things you can do. You can do all of this one while you are doing histogram. So this is one of the examples that you can do. Maybe I will put it. Maybe you can check it later. Then we can see. We can say for our dataset plt.figure. I'll say figure, and then I can say that plt.scatter. Scatter on what? I said that df.income. I will just make on my income, and what my income, and my income. So maybe purchases, you can say purchases. Okay, purchases, my income and purchases, and I can say that plt title, I'll say income versus purchases, and plt x-axis, x label, my x label can be income, and plt dot y label is my purchases, and then I can say plt dot plt show. If I show this one, it should work. Income. So because I have put why?
Quotation.
Oh,
Quotation it did not
yeah.
work.
Yes. Good. Thank you. Yes, you are right. Thank you. So this is my income is like here and my spending is here. So it's just like sometimes even you can find it from here also. Scatter plot, you can find many of them. Even you can, if you go to here, whole is here, histogram. This is violent plot that we were discussing. You can see this is, and you can find all of them here. What was histogram? Histogram. No, scatter. Let me search. No, this is the search engine from here. So these are all things you can see. I am sure you can for display, so you can read this one. I can just go. I don't want to search this much, so I will just go. I will go here. Histogram no escape. Plot in matplotlib. So you can see scatter. So it will give you. Or I can it's here. So you can see scatter is there is two, one x and y. So there should be two because it's bivariate. So you have to have two variables. Then you can have these all. You can read float numbers, optional. These are all optional. If you might edit or no markers, I can go and see here if there is some example. This one. You can see there are some variables. There are some random numbers. List of array of 12. This one is x and y. You can just do it. And one group two, and this is red color. Color is here. You can group one. You can group is B. So you can just make it a very beautiful based on what you want. Okay. What else you can do? Maybe we can go for income. We can have box plot. Maybe we can see outliers or maybe like this dot figure. So you can just write and just you can go and see like df in which data frame I say income and I can say income dot plt no plot what should I plot? So it's a box plot. So if I say plt dot title, maybe I want to do title, I say box plot and I can see plt show. So it's just like you can easy. Now then you if you need color or something based on this one, you can see. So this is my box plot on income. So I can do whatsoever. Maybe purchases for H. So this is the H because one is 130, so it's an outlier. Can you see? So this one is an outlier for my H because I had one H. It was 130. So like this, you can play around and see everything in your notebook. And there is a very good. So you can use this library, or you can use maybe Seaborn. If you need Seaborn scatter plot, so it has its own. It's the same, but they have some edit. They might have some add some more functionalities inside. If I go here, scatter. So you can use PLT or scatter. So you have two variables the same, like bivariate. So you can have numerical variables for x and y. So you can see all of them here. So it's like this. There is, and this is load. There's a data set, a built-in data set. So it's loading this and it's showing this one. So you can have all of them here or this one. So you can use and you can find out a good graphs for yourself and you can do it based on yourself, based on your need. Maybe scatter violin. You can have your violin. So these are you can make like such like these graphs. and images. You can go and see. So this is available graphs. So there are plenty of this one, but the question is that visualization best practices, that is very important, that we should always keep in our mind. Keep charts simple and uncluttered. Like you can see here, that this is the problem. What's the problem? Avoid unnecessary grid lines. Here, if you see the backside grid lines, mostly we put grid lines. So it's somehow, if you think it is just like, sometimes it is unnecessary. If you can see in here, there is no any grid line, so it's after is very beautiful compared to before this one. And also 3D effects, like I showed you bubble chart, but in most of the time they say that it should be 2D, not 3D. Your graphs should be in 2D, not 3D. The effects or something that you are making it more complicated so that the person should not understand, it's very bad. And also excessive decorations, if you make it look beautiful, but sometimes it might look ugly because people, they want to see your findings, not your graphs. That what have you done, and what is your main what was your storytelling, or what was your assumption, and what did you prove, was it good or no. So they will not see the graphs, they will see your findings and the result that you are having it. So highlight key patterns, not noise. So it should be only important data sets, important things should be fit inside this one, and simplicity improves readability and impact. So as long as it's simple, it's more readable and impactful. So you can see here, use clear titles, labels, and legends. So it should be clear. You should, like, flavor preference by gender. So I can understand that what is it? It's flavor preference, the people like male and female by gender. So, and a good title should explain what the chart shows, not just the variable name. So it's just like if I say gender, so it's not giving you. But if I say like gender distribution based on their preferences, on flavor preferences, or something like this, then I can understand that it's about their taste. That if some people like chocolate, some people like strawberry, so I can understand. Tables and legends should be short, clear, and descriptive. Place the legend close to the data for quick references. So you should do all of this one. It should not be far, it should be a little. But in here, there is no any legend. You see in this graph, there is no legend. Oh, this. You can see here, this. Oh, this legend is here. So visualize, like choose scales carefully. Can you see here, scales are here, like it's from 10-10, but you can make it 20-20 because it should be give you a little bigger like image. You can see here its scale is by 20, but it's by 10. Always start numerical axis at 0 when appropriate to avoid misleading patterns. Starting is 0, but later you can make it your scale like 20, 20, 20, or make it 10. It's up to you. But it's beginning, it should be 0. So use logarithmic or custom scales only when it enhances understanding. So you can use like a logarithm function, like logarithm, because it's exponential or logarithm function. When it is like, it will give you understanding from your data set if you have. So because if there might be some, your data might be in millions or something, so you can make as well. So keep scales consistent across related visualizations. So colors choose intentionally. So the color is very important. So you have quantitative, sequential, and diverging. So color should be highlighting meaning, not decoration. So it should be meaningful, not decoration. So you can, it's all English. Use constraint colors to emphasize key points. Stick to a limited accessible plately for clarity and accessibility. So this is your set 1. You can use red, blue, but mostly people nowadays they prefer not to use red because it's a color of dangerous or some not good. So you can use maybe dark color, maybe light colors. It's up to you based on your preferences. Or you can have one color sequentially. So this is one color based on this one. So because for example, for area, for showing like in map, it's mostly used sequential. The more it is darker, it shows that population or that means or whatsoever is expected to be higher compared to the white areas. So this one is diverging, so you can change colors up to yourself. Avoid relying on colors alone. Use patterns or labels when possible. So you should use like labels or patterns if there is So you can see here this color. Be consistent across visualization. It should be one of the same. They use the same color palettes, font, and scale for related charts. So you cannot have one of them with maybe with Camberley, another time series Romance. So it should be all consistently the same across visualization. So there should not be ups and downs. If you are using the font for all the graphs should be the same. It should not be that one should be 20, the other is like 200, the other one is 0 or something. So you cannot. So keep legends placement and formatting uniform, consistent improves comparisons and builds visual styles. Yeah, so this is an avoid 3D effects. So you can see like your backside for this green, your data is missed. You cannot find it from here. You cannot read. So you have to turn or you have to shift it to this side so that you should understand. But if it is in 3D, you can understand what is it. So you can compare easily. So prefer flat 2D charts. So it is like use depth only for 3D rare. It's very rare because there are some data I cannot. What is it? I cannot understand from backside. And also like keep text readable. You can see here this pattern is not ideal, so you can say not ideal like if you're writing like this, so it should be like in like this vertical. Is it vertical or horizontal? Are you here?
Yes, sir.
Yes, sir.
Okay, I thought you were sleeping. So ensure legends and titles are easy to scan. So you can see like it's great one. But if you have to turn your computer or laptop to 90 degrees so that you should understand what is it. But this is better, like Russia, US, something like this. Okay, focus on the story, not decoration. So it's all about you can read one, avoid distracting colors, shadows, icons, and animations. Use intonations to keep highlight points. So it's all about you should do it. Always double check for accuracy. Accuracy is here. So in here it's not started from 0. Can you see? Always verify data source, scales, and aggregations. Clear labeling builds trust. So if you have very good labels, legends, everything is fine. So your client will understand that you have worked hard and he or she will trust on you on your findings. So color theory, you can see here color theory categorically plate. Use distinct colors for separate groups. You can see here this one is for separate for light blue, like this all are different. Sequential is like a hue light to dark, so you can see from low to high is one color. Diverging is two constraint colors, like you can see like this is maybe this color or this color. So this is one, but it's into two portion, maybe for female and male portion. You can say profit versus loss. So there is this one is loss and this is profit. Don't rely on colors alone, so it's all about same. So labeling, you can go through title, clear, state what the chart shows, subtitles, axis, legends, and callout. So you can go all through this one. So storytelling is the art of communicating information in a structured, engaging way, turning facts and data into a clear, meaningful narrative that connects with your audience. So make information easier to understand, help people remember insights, because graphs can, if you show any graph or some images, so people can remember those for long term. Guides decisions instead of overwhelming with numbers. If you show your data set to them, like some dirty or some clean data set or whatsoever, they will not understand what data set is. But if you give it to as a graph, so they will understand the graphs better than the numbers. So connect logics with emotion. You should be emotionally, like you are saying about genders, people using alcohol or something. So it's emotionally or maybe other portions making data more convincing. So you can add more when you are going to tell about story data. This is telling a data story. So you have context, frame the problem or question. First of all, explain what is being explored and why it matters. Like customer churn increased 20% in second quarter. Insights show what patterns or findings emerged. Use visualize to highlight key trends, anomalies, and relationships. Impact, connect findings to action or significance. Explain why the insights matters and what it affects. So these all are logical sequence. Build a clear narrative path. Arrange, visualize in problem, insights, and impactful flow. Headlines, note labels. Engage and inform quickly. Replace vague titles and with insightful headlines. You can see the examples here. You can go through this one. Main takeaway per chart. Keep audience focused. Highlight one key message per chart. So if you are having a lot of variables, just try to make per chart one message. That what should I understand from your one chart that you are giving. So you should not put everything inside one chart. Just try to make it the message should be clear by one per chart. Guide the audience. Make the story easy to follow. Reduce clutter. Avoid too many visualize at once. So this is ethics and bias in visualization. Avoid misleading access. So you can see here, don't over exaggerate difference. So if there is something very small, but if you start to exaggerate and because exaggeration leads to misinterpretations, be transparent with data. Don't cherry up data. It means omitting data can be biased perception. If some is not according to yours, so you should delete that one. So don't delete that. Also show uncertainty when relevant. Help audience understand confidence and variability. So use error bars, confident intervals, and shaded regions. If there is something not clear or something, so you can just show them. Or you can show your, like if you are doing statistics, so there might be error. So you can show your errors through bars or something, that how much errors do you have in your data or something like that. Acknowledge influence, and also integrity is equal to design plus honesty. So this is very important. A beautiful chart means nothing if it's misleading. So if it is you are playing with if you are biased, so it means it's not good. And people, so you should prioritize truthful representative over anxiousness. So you can have accurate scaling, transfer labeling, and clear methodologies. So libraries, you can see here, there are plenty of this one, Matplotlib, Seaborn, Plotly. So for interactive web charts, so to make it more beautiful, so you can use this one. It's used for statistic plots, and this is the core. So first of all, they Matplotlib. So we have also this one, Altery, for declared visualization. We can go and see. Python, so we have so we have another module. You can see this one, maybe examples. So you have like these examples. You can save this one, you can view. So this is the code and you can just make it. So this is the modules. And you have import, you will import this one, the module, and then you can run. So if I just try to run this one, I should get this code. See, because first of all, I have this, I will just import this module or library, then I can use. So this is some random data frame they have created ABC. You can see ABC and their values is like this. So if from this and dot chart source, so you can see and encode AB. So it's giving you like this. And the same it goes with other ones. You can find plenty of graphs. So this is simple bar chart. You can have like simple histogram. Like you can just copy paste this one, maybe go through this as per your need. So you can just take these codes and you can replace with your own data frame. So you can just change your source here. So this is all about these graphs. Then we have another graph. There is like Bohi for website dashboard. I have not used this one. Let's see. Bohi Python. So this is another plot. So you can use this library. So you can make these complicated graphs. Can you see? So this is like interactive tools. So makes it simple to create common plots, but can also handle custom and specialized C. So you can see like this. You can make like these ones for dashboards. websites for your website. You can have, so it's up to you that which module or library you are going to use it. And this one is in GitHub, so you can see it can, and it has a community. So there are announcements, you can come and see. So people are making, so this person see is making such graphs or something like that. So it's and this code is here. So people, they are denoting their codes, they are writing and they are giving to the people to reuse. So you have tutorials, you have demos. I can go to demos. You can see here, this is the graph for movies. So I can play with this one and I can review length. So you can change. I can make tomato. This is all the things you can box office in millions. So this is like some of the reviews. So this is about movies. There might be some data set about movies. So they are exploring the data set about movies. Their box office dollars, box office, how much did they earn, and when that was released, and when did it finish. So it's all about, and did the minimum Oscar win one. So this is one of this movie, Avatar. Avatar earned this much money, and it also won one Oscar award. Avatar, and this one is Frozen in 2013. So it made this much money, and it won one Oscar award. The Dark Knight, and also Toy Story 3. I think you have seen Avatar, yeah? So this movie, which one was it? Is it in 2009?
Excuse me, sir,
So
I
this
have
is,
got a question.
yes, please, Mariam.
Yeah, only through copying these charts to our Python, the data will automatically be adjusted with the chart?
No, the thing is like this data is for themselves. So you'll change according to your data set if you need those one. So you'll change it accordingly. For example, see here, this is data. So this is data for temperature. So you will change if you need this one. So you will put your own data. So you, instead of New York, you will put Afghanistan, your this, or you have any Excel sheet or something. So you will just make those ones. Did you understand?
Okay, so we should copy the chart and also put our own data, then it will be adjusted.
Yeah, because this data is like this one is this data is here. This data. So it's on them. So they have just used some dummy with data. It's not like real data because they only want to show that how it works. Then you can change your. So this is the sources here. Data.scars. If you go here, so this is another data that they have used in this chart. So if I go here, I can see. So this is the data for this. I think, yeah. So this is car sales.
Okay.
This is
Okay,
the
sir.
data.
Understood.
So this is data.cars. If you see data.cars, it means that they have used this data. So you can download here, maybe with this one or something. So you can see the data. So they have used this data to make such graphs. So you, instead of this data, then you will use your own data if you want to use your own for your own data set.
Okay, sir. Thank you.
Yeah. So this one is like you can see they've made like these movies, and you can see Avatar. So these movies they have won Oscar. So you can see maybe there should be one Oscar here and there. So this much money they have were. So this one is here. So how much was it? It's more, but it was in here showing this much. So you can use such data types and you can have more. And there is another one, Spiegel. You can see here. But I recommend you, this one is another one, so you can see. This is the documentation, so you can go and read. So this is another way. So it's up to you that which one do you need based on your research, your work. If you need such ones, you can use these ones. If not, so you can use simple ones like matplotlib and Seaboard. So you can use other ones. Okay. Do you have any question, guys?
No.
No, sir, no question.
Yeah.
Oh. What is it? My graph is not looking good, teacher. How is it looking? Fine, maybe because you can now we can play with Zohra, you can play with, you can remove grids, you can make another one. So at least you have made the graph, so you can use it. You can change the color if you wanna have your colors. You have your bar charts. It's histogram, yeah? Was it histogram?
Yes, sir.
So you can change it to the colors, your everything. You can make beans, everything based on. You will go to, you. So when you are not satisfied, what you will do, Zahra and other, you will go to this one, maybe for histogram. Where is histogram? Okay, histogram is not here. Okay, then you will go to. I will open here. So histogram. So it was matplotlib. So you can use plotly maybe. So maybe you can find histograms in Python, plotly. There is another library. If you don't like that one, so you can use another library or another. So this one is another one. So it's giving you like this. So it now in here, what is it? So you can just select a portion, you can select it, and then maybe not a select. So you can take a download the PNG, but you cannot do it in that one. But with this library, I can do. Now I can. Okay, let me run here. Now, here I can use many things. I can download this one as a PNG. So I will just download. It will take now. See, I downloaded. Now with this module, with Plotly, I can download the image that I'm creating. So I don't need to, like, this one I cannot do anything. Yeah. Oh, I can do it here also. Yeah, good. No, this one is no, not this one. This one is the advanced graphs. Yeah, this one. For example, with this matplotlib, I cannot do it anything. I cannot download. So, but with this graph, with Plotly and this one, I can just download. See, I can see the source. I can do everything. And with this one, so I can see how it's working. I can see all of them together. Then I can see select a portion, maybe this portion. No, that is not working. So zoom in, zoom out, so you can see why it's not working. Right. So you can have zoom in, zoom out based on your scale. And here also you can have it. So you can play with all of them based on your graphs that what you need. So with this one also I can download CFC. I can save as CSV file, PNG. So this is because I'm using this alt here. So based on your need, what of kinds of graph do you need? You can use different modules and libraries. Do you have any question, guys? Is everything clear?
Yes, teacher, it's
Yes,
clear.
clear.
Perfect. So let me share your quiz, and I will give you assignment today, maybe because you should try to work with maybe with some graphs, some playing with some dirty data, just or maybe clean data. It's up to you. Okay. Just give me a second, please. Let me stop recording if there is no such thing.